Hello and welcome to Channels, the Nextflow podcast. My name is Phil Yules. I'm based in Stockholm and I work for Secura as a lead developer advocate. Joining me today we have Marcel.
Hello everyone, I'm Marcel, speaking from Brazil. I'm a developer advocate at Secura, working mostly in the Latin America and the Caribbean region. Nice to see you guys here again.
And very excited to invite back today Ben Sherman, software engineer at Secura and working on Nextflow. Ben, do you want to say hello and just tell everyone about yourself quickly?
Hey everybody, Ben Sherman, Nextflow developer. Excited for round 2. Here to talk about some more exciting updates we got coming down the pipeline for Nextflow.
So anyone joining who's maybe new to the podcast, if you go back a couple of episodes, you can find our first interview with Ben, where we delved into some details with Nextflow. And when we were talking to Ben about setting up the podcast, about what different topics, he came with so many ideas. We were like, okay, there's no way this is going to fit into one episode. And before we knew it, we're like scheduled up until like October. So today we tried to organize all these ideas a little bit. And today we're focusing on power to the process. So we're talking about syntax updates, which are coming for Nextflow language updates, the nuts and bolts of building a Nextflow pipeline, and specifically cool new features which are coming to process, right? I mean, Marcel, give us an intro. What's a process in Nextflow?
Yeah, so the process is this definition that we have. A Nextflow process is the description of a task, a step in your pipeline, right? So if your pipeline has conceptually, let's say, 10 steps, usually you would have 10 processes or something like this. And then whenever you have some data, some element to go through this process, this step, you're going to have a task, and then you can have multiple tasks for the same process. So if you look at Nextflow as the scripting language compared to other workflow languages, it's a much more powerful language, right? So DSL is a domain-specific language that allows you to do very powerful things for your pipelines. But the thing is, even though we are already this very powerful language, there's so much more to do. And Ben has been the main person behind lots of improvements who are making Nextflow an even more amazing language. And I think that one thing that is very interesting and Ben has been working a lot is about having default values for process inputs, which is something that we can kind of do, but it's going to be much better now. Can you tell us a bit more about this, Ben?
Yeah, so I'll give my usual caveat for talking about this stuff is that nothing is set in stone until it's merged, right? So these are all, some of these ideas have PRs and they're basically ready. Some of them are still in development, but I just want to keep everybody in mind that like what you hear on these podcasts is mostly just like a prediction, right? So we hope this is how it'll turn out, but you never know. Sometimes things change. But with that being said, let's get into it. So the default arguments. So what this is about is that a lot of people have asked for having optional inputs in the same way that you have optional outputs, right? So you can say in a process, I want this output to be optional, and suppose it's a file. Well, if the process doesn't produce that file, then Nextflow just won't emit anything. Whereas if the file was missing or if it wasn't optional, it would have failed, right? People want to be able to do that with inputs as well. But the thing about optional inputs is that when you're talking about data flow, which is sort of the paradigm that Nextflow uses, you have to think a bit more carefully about what you mean by optional. Do you mean that it needs to be like a null value, but there's still like a value there? Or do you just want nothing, right? Because there's a difference there, right? Think about like when a process emits a null value, that could trigger a downstream computation. Whereas if a process emits nothing, then that will trigger nothing, right? So what I
remember last week I did a seminar with Harshal where we went through some NF Core development practices, and I remember him doing this. Actually, he installed an NF Core module into a pipeline, and as he was wiring it up, he was like, "Oh, I don't care about these 2 channels, so I'm just going to put like an empty list here." So I'm giving it a value, but that was at the pipeline level, right, when he was invoking the process.
Right, exactly. And so what I landed on was that there's a couple of more specific features that we should implement instead of just having an optional input. And the first one of those is having default values. So basically, and this is probably the simplest one to understand, right? Because it's basically just when you define the process, you specify a default value for an input. And then when you call that process in your workflow, you can just not provide that input and it will use that default value instead. It would be as if you provided a like a value channel or just a raw value, right? So it'll just be reused every time that process is invoked. It'll be reused instead of what you could have provided. And so that's basically all it is. It's useful for any of these processes where you have, I think multi-QC is probably the most famous example of this, where, you know, multi-QC can take in like dozens of different directories, right, for different tools. And what the NF Core guys have done is they've defined a separate input for each one of those directories. But then that's real annoying if you want to use that process, maybe you only need a few directories, but you still have to end up providing, you know, like an empty list for every single one of those inputs. Well, what we could do now is just add those as default values into the process. And then if you only need a few directories, you would just use those, right? So that can make stuff like that a lot simpler. The caveat with this is that because the process inputs, when you call a process, are provided, you know, just as a list, right? They're not by name, they're by index. Your default values all have to be defined at the end of your process list. So if you have a few inputs that don't have a default, then you have a few inputs that do have a default, the default inputs all have to come after the ones that don't. Because if you think about it, suppose that your first input had a default value, but the rest of your inputs didn't. That would be useless because there's no way to like skip it. So they all have to be at the end. So you have to order them a particular way. That's really the only thing.
That's kind of a convention for command line tools and stuff, right? I'm pretty sure I remember that with Python packaging. If you're using click or something, if you want an optional input, it has to be at the end. Oh, sorry, optional argument, positional argument.
Yeah, pretty much any language that supports this with like functions works this way. If like in Python, if you want to supply a default value, it has to be at the end, right? Or in Python, they would call them like named arguments versus positional arguments. So yeah, it's basically the same thing as that.
Are there any limitations as to what the default values can be? You mentioned it could be like a value channel. Is it kind of can it be like, does it have to be a channel? Can it be a variable? Can it, you know, what kind of things can we put in as defaults here?
It could be any just regular value. You don't have to worry about channels. I would just put in like just a raw value. Typically it would be, you know, like 0 or an empty list or something like that, right? Actually, if you guys want, we could pull up the PR and then I could show you some code examples. So here, and by the way, these you can see all the PRs here. Green check marks, love to see it. These PRs are ready to go. Let's go look at the PR for default values.
Anyone listening to this without video, by the way, don't worry, you're not going to miss anything. We'll post the links to these pull requests in the show notes, and we'll talk through what we're looking at as well.
Yeah, feel free to look at these yourself. With all these PRs, I try to make them set up so that anybody can go and look at it and immediately understand how it works. So it's not just code, right? I've also added the documentation. So you can see here like what the documentation will be if it gets merged, which basically just the explanation that I just gave. And then if we go down to the bottom here, we can also see a code example. So here's a full pipeline, just like a basic pipeline, single process that is using the default values. And so you can see here, I actually base this, I think, off of multi-QC, right? So I just think like, okay, we've got 3 different directories here of folders of files, and we want to be able to only specify some of them. So it's just like any other option that you provide to a process. It's this syntax where you have a comma and then the name, value, right? So we're just saying, if you don't supply this value, it'll be an empty list. And then down here, when we call process foo, I've given it the metadata here, because see this metadata, oh, there's my translate thing popping up. The metadata is required, right? There's no default value. So I can just supply the metadata, and then all of these will just use the default values. And then if you run it, you'll see it go through this code here where it checks the folder. And then if the folder's not there, it will say, I'm just going to skip it, right? And that's it.
Can you have a process which is... Oh, sorry. Go on, Marcel.
No, you can go.
I was just going to say, out of curiosity, what happens if you have a default value on everything? I guess You still have to call the
then,
process, right? So it doesn't really matter.
Yeah, so then you could call foo with no arguments, but that would be kind of useless, I think, right? Because you're not actually giving it real inputs. So you could do that. I'd be curious to see if somebody can come up with a practical example based on that.
Yeah. So I think that's a great example to show a few things. Like I really love the Nextflow documentation. And in some projects, you have lots of new features, but they don't appear in the documentation. So it's like a secret, but very few people know how to use the features, right? And one thing I love in Nextflow is that you can see like a lot of the recent, I mean, most of the recent, if not all of the recent PRs, you always have the feature being implemented in the documentation, the same PR. So you know that as soon as it's going to be available, you can go to the documentation and read it and see how it's done. That's very, very nice. I think it's also a good opportunity maybe to teach a few things about the way Nextflow works. Very often people ask on the Slack, like, oh, I'm running this pipeline, but nothing's happening. Like the process not doing anything. Or the process running twice, but it should run 4 times. And the thing is, if the channels have no elements, the process doesn't run, right? This would be an exception with the default values, right? If you have a default value, then we're going to have a task. But if you don't have default values and your channel has no elements, or you have a channel with 3 elements and the other one with 2, and they're both queue channels, 2 times only. So people are always messing this value and queue channel thing.
That's a good edge case, but I guess default value won't do anything if you pass a channel which is shorter, right? Because you're still passing a channel, so the default value won't kick in.
Yeah,
it's not like it's going to roll over onto the default value at the end.
Exactly.
Right.
All right. Should we move on to the next one?
Yeah.
I don't know very much about this, so you're going to have to really lead me through this, Ben. I've got written down Arity. Are we still screen sharing, or should we just chat for a bit?
Yeah, we can take off the screen for a moment because we can just talk about this. So this is the other side of what I was talking about with optional inputs and what that means when you're in data flow. So I'll talk about nullable first. So we've got Arity and nullable, and these are both. These are also just both options, kind of like default value, that would apply to inputs. They apply specifically to path inputs. So the first one is nullable, and this is what I was getting at with having no value versus a null or empty value, which is that sometimes you actually want to emit some sort of null value with an optional path rather than emitting nothing, right? So if you set an output path as optional and it's not there, then it will emit nothing, which means that no downstream computation will be triggered. Sometimes you might have a case where maybe you have like a file pair and one of the files could be optional. In that case, say like maybe you have a tuple with 2 file elements in it, right? And one of those files could be null. Well, you actually need it to emit something there, right? You need it to put a null value there. And so what we've thought about is just having an option called nullable, which you can specify, which says, hey, in this case, if the file's not there, instead of emitting nothing, just emit a null value. And then on the flip side, you could have an input path and set that as nullable. And then if that path receives a null value, it will actually work. Whereas if it's not nullable and it receives a null value, it will fail. This is a concept that, depending on which programming languages you have experience with, you might be familiar with or not. A lot of languages like Java and Python and C, basically everything is nullable by default. So if you have like a string value or a custom object or something, you can just set it to null and then you're good. A lot of languages like, Haskell, Rust, there's a few others that I can't think of at the moment. Actually, nothing is nullable by default. And if you want something to be nullable, you have to set it explicitly with something like an option, or the functional programmers call it a maybe. Basically, there's an explicit type for nullability. And Nextflow more or less follows that concept when it comes to paths. So when you have an input path in the process, there has to be a file there. It can't just be null. But like I said, sometimes there's cases where you want it to be a null. And basically, like I said, if you have a file pair, maybe one of them is optional. Maybe you want the process to be able to operate on just the one file if it's there, or the file pair if both are there. So nullable will basically facilitate that. And then now you'll have nullable or optional, depending on how you want the data flow to work.
So does this then take that use case that Marcel was just talking about, where you have input channels of different lengths and it stops after the shorter one? If you make them nullable, would that keep running then until the longer one is exhausted and just put in null values? Or am I misunderstanding you there?
Not necessarily. So if you have two channels, one with 3 items and one with 2 items, then it'll run twice, right? The way to think about it is that the nullable would allow you to insert with nullable, you might have additional null items. So if it worked out so that channel with 2 items had some nullability in it, and now it had 2 items and then a third null item, then yeah, it would run 3 times. And that would be an important difference, right?
Exactly. Very good point, Joe.
So we can pad out our channels now with nulls.
Yeah. I mean, I definitely, with this feature, I recommend that you use it with caution, right? Like, don't use it unless you really need it. In general, it's much better to just try and avoid nullability in the first place, and just because it can cause issues, right? The null pointer exception is a very common error that programmers run into. Actually, the guy who invented the null value back in the 50s or 60s calls it his $1 trillion mistake, because he believes that null pointer errors have caused about $1 trillion worth of errors. So, but
no pressure.
if you absolutely need it, it'll be there for you.
And sorry, and maybe you said this, but is this a property of the channel or of the process input? It's the input, right? Not the channel.
Yeah, so it's defined for process inputs and process outputs, specifically path inputs and outputs. So any path that you define in your process inputs or outputs, you can add the nullable option. And then the idea is that you would need to have like a matching pair, right? For every nullable path output you have, you would need to have some nullable path input downstream that could accept it, right? So, yeah.
Makes sense. I told you you'd have to lead me through this one. That's good. All right, and then what's the Arity thing?
Yeah, so this is probably one of the more in demand, more like demanded features. Basically, there's Nextflow has this quirk where if you suppose you have a path output on your process, and maybe suppose it's like a glob. So you're saying like star.fastqc, basically saying however many fastq files are produced, just grab all of them and output them into this channel, right? What Nextflow does in that case is if there's a single fastq file that's produced, it will return it as an individual file. But if there are multiple files, it will return it as a list. Now, to people who don't program a lot, maybe you don't think much about that, but a lot of experienced programmers will see that and immediately cringe, because anytime a function returns a different type based on the runtime conditions, that is really annoying. And the reason why is that if you have to use that downstream, well, now every time you use it, you got to check, right? Because you got to see, well, is it a list or is it a file? Because depending on that, it's going to have different operations available to it, right? Like if it's a single file and I want to like get the length of the of the list, I got to wrap it in a list. Otherwise, it's going to give me literally the length of the file path, right? That's typically what happens is people try to get a length and then they get something like that. And just these really bizarre errors. And this is just
ringing
something
bells. I'm pretty sure I've come across these kinds of bugs in my early Nextflow programming days. Like, what is going on? It worked fine, and then when I run it with one sample, it crashes or does something really weird.
Exactly. Yeah. And so, it would be nice if we could just fix it, right? And just have it not do that. But we like to try and maintain backwards compatibility just because Nextflow evolves so quickly. And so what we've come up with instead is an option which we call Arity. This is not a very common term. It's sort of a computer sciencey term. Another term would be like cardinality. It's basically just like the number of arguments. So like say if you like call the function with 3 arguments, you could say the function has an arity of 3. Just basically means it expects 3 things. And so we use that here to allow the user to define for a particular path input or output, how many files are you expecting? And the cool thing about this is that it can be a range. So you could say like this input has exactly one file or exactly two files or however many, or you could say this file, this input could have anywhere from 1 to 3 files. Or you could say, you could use a star and say this input has anywhere from 1 to star files, which basically means at least one file and then any number beyond that. So it's like an open-ended range, right? And you could even say 0. You could say this file could have 0 to 1 files, and that's effectively like an optional. I think that's where the arity would kind of clashes with the nullable, where you could say arity 0 to 1, or you could say nullable. Probably we'll tell people just use nullable. We'll have to figure out exactly where the boundary is with that. But the point is that the arity is a range, sort of a range notation that allows you to define what are the possible number of files that is allowed here. And so what Nextflow will do if you define the arity is first it will make sure that it has those number of files. That's sort of an added bonus we get out of it. So if you're expecting 2 files and then only one of them was produced, normally Nextflow would probably not catch that, because say if you said star.fastq, but you were like, really, I want there to be exactly 2 files, right? And then it only caught 1, it'll be like, well, I caught all the fastq files, so we're good to go, right? Now you could say, I need to be exactly 2 files, and if there aren't 2 files, then it will fail. And then on top of that, it will, well, now I can't remember how it handles the list flattening. I'm pretty sure it still does this thing where it, so I think if you, basically, if the arity could be more than 1, then it will always return a list, even if only 1 file is produced. That's it. So it provides more consistency there. It would only return a single item if you explicitly said that the arity is 1, right? In that case, it would return just the file. But in any other case, yeah.
So at least that's now predictable for the pipeline author. You know what you're going to get. And more opt-in validation is never a bad thing.
Yeah, and I was checking the source code of the PR, and the error messages are really good. Like, it throws an exception: incorrect number of input files for process. This one expected this arity, found this one. So it's very clear when this happens. The message is very clear as an exception. Things terminate. You know what's wrong. You know what was the arity on the runtime. You know what it should be, but you already know, right? You're set, and then you can see what's going wrong to debug your code. I think it's a great way forward.
Yeah. Exactly. Let's actually pull up this code and I'll show you guys what's going on here. So I'll skip the nullable. If you want to look at the nullable, it's right there. It's the same as all these other ones. If we go into arity here, first of all, you can see, right, there's like a whole history of issues, right? This is one of those epic issues where like every few years someone new comes in and they report the same thing. I try to keep track of them. You can see that's the history of all this. It's basically the same thing going on. And if we wait for GitHub to load, we can see here, okay, yeah, so, well, documents are a little bit clobbered because I did some messing around, but let's just go down to the code example down here. If I can find it. Okay, it's down here. So, yeah, so here's the sort of end-to-end test. Now we've got 2 processes, foo and bar, and I try to demonstrate all the different sort of combinations you could have, right? So here's a file called 1.txt. Obviously, it's always going to be 1 file because there's no glob, right? So we'll say, hey, the arity is 1. So this should always be a single file. This one is probably fine. You probably wouldn't have an issue with this one because there's no glob there, but it works in case you want it to. And then here we've got something more where you've got a glob. And so, but you actually know that there's going to be exactly 2 files. Now, sometimes you can handle this with a glob where you could say like pair, and then like with curly braces, like 1, 2, if you knew it was going to be something like that. But you could also do this and then say, I want exactly 2 files. And then you see down here, it's creating a pair 1 and a pair underscore 2. And then here's the more dynamic one where you've got many underscore star, and you want to say there could be 1 or more files. So we'll say a 1 ... star. So the arity value is always a string, and that's how we're able to do this special little mini syntax here. Is basically just lower bound ... upper bound, right? And so this could, in this case, we're producing 3 files. But even if I took out this part and I just created the many 1, that would be valid, but it would still be emitted as a list. because Nextflow will see that, hey, this Arity, this is really a list of values, right? So we're always going to put it as a list. And then here's a way you could sort of make it an optional, where you could do 0.1. And then if it doesn't emit the file, which in this case it doesn't, then that will be fine. Now, I think what's happening here, because we're talking about, is it optional or is it nullable, right? And I think in this case, it is actually optional. So, well, you know what? It's been a few months since I've worked on this, so I actually don't remember. It either emits nothing or it emits an empty list. I'd have to go check that again. That might be something we need to document. Honestly, I recommend again.
This is like rubber duck debugging on air here. I like this.
Yeah.
You never really know something in depth until you try and explain it to someone.
Probably there's no need to do this. You could just make it nullable or optional instead. That might be a bit more of a cleaner way to do it. But because it's possible, I want to make sure that it at least works and doesn't explode, right? So we have it in there. And then you can see on the flip side here, so similarly to how you've got with nullable, you would want to have sort of matching outputs and inputs, right? You got the same thing going on here, where now we've got this process bar that's accepting all these outputs here and then inputs here with all the same sorts of arities. So we can verify downstream that, all of these inputs coming in are matching the arity that we expect. So we expect one file here, exactly 2 files here, some number of files, at least 1 file here, and then an optional file, and then we're checking it here. And yeah, that's it.
So I just wanted to without going too stray from the conversation, just one thing that by listening to your explanation, I thought of something that is very commonly asked in the Slack, which is, my process generates 1,000 files. I only care about a few of them. And okay, if you set the output correctly, it's gonna be only links for the ones you care are gonna be created in the task of the next process, right? But still, you're wasting this storage in your work directory, right? And then one thing that some people do is, like, you use the scratch directive, process directive. You're gonna have a temporary folder for that, and only the ones you care are gonna be in the work in the end. So it's very dissociated from what we are talking here right now. But just remember this tip, which is very commonly asked, is like how can I decrease the usage of this storage for my work gear? Scratch is a way. Like when you're showing this parity things of it's gonna be 4, I only care 2. I remember this thing. So just a minor comment, a minor tip. Nextflow tip.
Well, it's actually interesting that you bring that up, because it would be interesting to see how the Arity interacts with that scratch storage, right? Because the scratch storage is interesting there, because the glob that you define here actually controls which files get copied back from scratch into the work directory. I'm wondering if, I guess I'm just curious to see how they will interact. Probably there won't be much, but maybe the added verification would be some benefit there. Who knows?
Very good, very good. The next one, I think we already mentioned a bit, which is the named arguments. And I think, even though I think Arity is very important, I think a lot of people complain about the lack of named arguments in Nextflow, right?
Yeah, well, yeah, so it's a common, like we were saying before, it's a common feature in programming languages, right? Or at least like Python has a good example of this, where you can define, basically when you define a default value for an argument, it becomes a named argument, and you can supply it that way. And there's this whole syntax for like passing a map just as a bunch of named arguments. Groovy also supports named arguments, and the way it works is, like in Python, you would say like name equals value, right? In Groovy, you would say name : value. And what happens if you call a Groovy function and you provide these named arguments, the syntax there is actually sort of like a syntax level transformation. It will take all those named arguments, gather them into a map, and then provide that map as the first argument to the function, which is a little bit weird, but that's how it works. And, a process is basically a function. So why not support that same syntax for the process? And so I implemented it. We can look at it in a moment. What I'll say with this is that this one is less set in stone than the other features that we've talked about. The reason is that it sort of introduces an ambiguity. So first of all, like the way the syntax works, it's basically just like all these other ones, right? It's just another option that you have available to you when you define an input. You can say, I think you can just say like name and then colon and then whatever the name you want it to be. And I've actually even got it to where if you don't specify a name, it'll just use whatever the variable name you specified. So if you had like val x, then it will automatically be available as a named argument called x. That works and unless you if you had like a path where you define like a glob, then it won't work there. But if you did define it with like a variable name, then it will use that, right? And then when you call the process, it was just like with a Groovy function, you can say like, name colon whatever for the input. And then that way you can specify them in any order you want, right? The ambiguity that happens here is that, okay, so now what happens is that Nextflow is going to receive all those named arguments as a map. And it's expecting that map to be the first parameter in the process, right? But the problem is that if you don't provide any named arguments, then that map isn't put there. So that first argument map isn't always there from Nextflow's perspective. And so Nextflow would have to check. Nextflow basically has to check and see like, okay, is the first argument a map? And if it is, we're going to interpret it as the named arguments. And then if there's no map there, then we'll just assume there's none. But
what happens if you have a mixture of named and not named arguments as well, and you get even more complicated?
Well, that's fine. So you would have the map argument, and then you would have all of the regular arguments, right? That's how Nextflow will see it, like internally. But then the problem is, what if your first positional argument happens to be a map? This isn't common because we don't have good map support. We'll get to that in a moment. But you can actually pass a map through a val input. And so what if you didn't specify any named arguments, but you had a val input on the first argument and it happened to be a map? Nextflow sees that. And so now it thinks that map is the named arguments and it's going to interpret it and explode, right? And you could say like, well, we could inspect the map and like check the keys and see if the keys correspond to like the inputs. But, people already know that like Nextflow is kind of bad with error messages, right? Like there's a lot of cases where you get these like weird error messages that are not helpful. And I feel like this is just going to make that worse because it's going to be like, hey, I got a map, but it doesn't look like the named argument. So I'm just going to, but maybe you mistyped something. And so like it gets all confused and it's just going to explode again, right? So this one, I'm not too sure about. Like, I'm actually not sure if it's something that we can support cleanly in the current DSL. Maybe in another iteration of the DSL, we might be able to get it to work. But
this is a good example of there's one of these examples of someone, you make an issue and you're like, come on, all the other languages do it. Why can't we have this? And when you actually start digging into the details, you just like kind of like get deeper and deeper into this rabbit hole and you're like, oh.
Exactly. That's why we still don't have it.
Yeah. Yeah.
Exactly. And also wanted to clarify, because we do have some named outputs already, right? You can do a named output for workflows and
emit, right?
Yeah, named outputs are stupid easy, right? You can just set the name on the output and then when you call the process and you can access it. That's really straightforward because there's no function call going on there. It's just an object with names you can have. So that's really simple, but yeah. If you want, we can pull up the code and I can at least show you what it looks like.
Go on, let's have a quick run over it. I must admit, I don't know about everyone else who's listening. It made my head hurt a little bit as you were going through that into
this one's a little deeper. Like, when it works, it's really simple, and when it almost works, it's super complicated. That's just how it is. But again, if you guys are interested in this feature, again, with all of these PRs, please feel free to go look at them, look at the code examples. You can comment on them and give feedback. We won't mind. We're always happy to receive this, right? But yeah, so first of all, you can see it's in draft mode because I want to emphasize this one is definitely not ready, right? It works. It's just that there's that ambiguity there. So if we go down here, you can see what it looks like. First of all, yeah, I think there's only one example here. I didn't even specify the name here, right? I just have val bar and val baz. But if you wanted to, you could say comma, name, colon, bar, or whatever other name you want in cases where, say, if this was like a path with a glob, you would need to do that, right? But yeah, so we have this, and then down here in this workflow, we're calling it here. So exactly like I said, we've got, so this workflow has inputs bar and baz, and then we're calling foo bar with bar and baz with baz. But, you know, if these were just like other names, then they would be here, right? And that's all it is. This example is fine, right? There's no ambiguity. So, you know, I guess I leave it up to Paulo. You know, if he's okay with it, I guess we can merge it. I doubt he will, because we all know how, like, you know, like stringent he is with this stuff. I mean, it has to be like perfect. So we'll probably need a little bit of more work on this. Oh, by the way, I didn't mention this, but this also works with workflows. So this workflow has inputs bar and baz, and then down here we're calling this workflow. You can see, and then we're doing the same thing: bar, bar, baz, baz. So
you threw me there a bit because the variable names are the same between the process and the workflow, but yeah, it's two separate things there, right? Yeah.
Yeah, and I guess the thing to mention is that you could specify these in any order, right? So I could say baz and then bar, you know, whatever order. So
cool. I think there'll be a lot of people happy to see this when it hits the big time. All right, on to the next one. Map inputs. I feel like this is going to be you've given us a good intro to this already. Where are you going with this? Map inputs and outputs for processes.
Yeah, so by the way, from this point on in the podcast, everything that we have is there's no PR for this stuff. We are going into totally like unknown territory. I actually have a little bit of code for this one that works, but it's sort of a very minimal like duct tape example. But yeah, so for map types, you know, a common practice in Nextflow is to use tuples. If you have some sort of composite type, like it's common to have a tuple that has like for like some sample, right? And then you have the first element is the metadata, like the sample ID. And then the second element is like the list of files. And then maybe you have multiple elements for different files, right? But then you have to remember how you ordered all those things. And so you have to remember like, okay, well, like tuple _0, this is the metadata and so on. If you're like accessing it in operators and stuff like that. So for a lot of people say, you know, it will be nice if I could access these by name, just like we were talking about with the named arguments, the functions. We'd like to be able to access, you know, like the elements of a tuple by name instead of index. And so that's just a map. Now, you can actually use maps already in Nextflow. Like I said, the val input in a process, well, a val can be anything. It doesn't have to be like just a raw value. It can be whatever you want. But the key difference between val and say like a tuple or like a path list, it really comes down to the file staging. This is the key thing that Nextflow does as opposed to if you were just like call a regular function, right? Is that when you say I have a path input, Nextflow knows it's a path, and so it applies all of the staging logic, right? It looks at it and say like, okay, well, this is like a local path, so I'll just link it in, or oh, this is an S3 path, so I need to like stage it into the folder, right? If you passed in a path string as a val, it wouldn't do that. It would just be like it's a string, okay? And similarly, if you passed in a map, it doesn't go and like try to inspect that map to see if there's any path elements in there, right? So what we need is an explicit map type where you would pass a map, and then Nextflow basically does the same thing it does with a tuple. So if you pass in a tuple, it looks at each element, and if any element is a path, it will stage that in. Same thing with a map. It'll look at all of the map values and then stage in any paths that it finds. And so the syntax would be very similar to a tuple. It's just that instead of saying tuple, you would say map, and then you would have to supply key value pairs, right? You would say like map and then metadata colon, and then, you know, the val metadata, right? And then so on and so forth for all your other types.
I never tried it. Can you do tuples of tuples? Can you does Nextflow keep interrogating it all the way down?
I don't think it does. I've wondered about the same thing, and I don't think it does. We could probably do it, you know, it'd just be setting up sort of like a recursive strategy. I guess nobody's tried to do it yet, and then it fails, and then make an issue about it, and, you know, they'll trigger that whole process. I think that would be nice. It would be nice to have arbitrarily nested structures, and then Nextflow to be able to recurse through all of that. I imagine that if we support a map type, something like that will probably happen. Somebody will probably have like a tuple within a map or a map inside a tuple, and then we'll need to do that, right?
Turtles all the way down.
Yeah.
It reminds me a little bit. Last week we were talking to an NF Core infrastructure team, and we talked a little bit about this NF validation plugin, which has come out of the NF Core community with Julia Nicholas. And we were just, when you were talking about meta, it's a very common pattern in NF Core. I think it's used all over the place now. And we've got now, with this plugin, we've got the from sample sheet channel factory. And you can see down here, if you specify in the sample sheet, where is it? Here it is, the sample sheet schema. We say it's a meta value. Then by default, straight away, we're going to start returning the meta from the sample sheet as a map. So you can see that we're using maps here already, and I think it works fine. So, I guess we're getting a tuple, and the first element of a tuple is a map, and then it's all strings, so it's sort of fine. But,
since there's no paths, it's all just metadata. It works fine.
Yeah,
exactly.
Nice, cool. Last one.
All right, we're almost there, folks.
We're almost there. Don't know about anyone else. My office is heating up. This is I've got the window closed and I'm boiling. It's good.
Very powerful. We're adding so much power to these processes.
Exactly. Yeah. No Nextflow.
So yeah, the last one I believe we want to talk about is custom record types, and this is basically just a rehash, just the exact same issue as the custom map types, right? People like to define custom types. So like, this isn't common, but you remember a Nextflow script is really just a Groovy script with a little bit of syntax sugar on it. So you can use all the same constructs from Groovy and Java, right? Including classes. What people will do sometimes is define a class that's basically like what you might call like a data class in Python, or a value object, where it's just a class or like a struct. It's just a class with some fields, no special methods or behavior or anything like that. It's just basically a composite type to make it easy to access elements by name. So it's kind of like a compile time map, right? And it's the same idea as a map. You want to be able to access the elements by name instead of by element. So you might have, again, like a record type. If you had it as a map, you would be like, well, actually in Groovy, a map, you can access a map the same way you would as like a record, right? You can say like, map and then brackets and then string value for the name, or you can just say map dot key, right? And then it'll just give you that. So same thing with a record. It's just sort of more like a more strong type information, right? Because all the elements will have a specific type. And then it's the same thing as before. Go ahead, Phil.
So I was going to say, I was chatting to, I think it was Niels Homer at Fulcrum Genomics about this the other week. I think he said his team was doing this approach already of using custom classes to pass metadata around, because they found it had better structure and better control over it. So yeah, it might be that some people are trying to do this already. I don't know how well it would work already.
Yeah, there are people already doing it, and there are people using maps as well. Basically, what you have to do is that you have to add this boilerplate code around all of your process calls, where you convert the map or the record to a tuple, and then on the other side, you convert that tuple back into the desired record or map. So it's the same thing. You can pass a record as a val, but then the files don't get staged. And so that's why you have to convert it into a tuple so that Nextflow understands it. So
can you do any cool stuff in classes like default values upon init, or any kind of additional validation, but within the class object?
Yeah, so you could have like a constructor that supplies the default values and provides validation, anything else like that you might want. And on top of that, Groovy has a lot of really cool AST transformations or annotations that you can apply to the class that just automatically gives it behavior. So like there's like a common one is equals and hash code. You could add that to your class. You would say ampersand equals and hash code. It will automatically add an equals, like a equals function and a hash code function, which would allow the record to be used inside as a map key, for instance. And then there's even more on top of that. Like, so Nextflow actually exposes, we've if you guys could pull up my screen for a moment, here's actually a cool little tidbit that we can show off. I actually don't even know if it's in the docs yet. I might have to pull it up in the Edge docs. Let's see if it's here yet. I think it might not be here yet. But what I could do is pull up the code, and so this is like bleeding edge documentation. All right, this hasn't even made it to the website, just the source code, but it's just Markdown, so we can just pull it up, right?
I was going to say, it's a good opportunity to point out that all of the documentation is just a bunch of Markdown files in the main Nextflow repo. I was pointing it out to someone the other day. Maybe not obvious if you've not looked for it.
Yeah, just go to the docs folder, and it's just Markdown. You can look at it. It's almost as good as the website. It's just some of this stuff doesn't quite work, but it's fine. If I can find what I'm looking for. So recently I added a section to the script docs that just describes all of the sort of built-in classes and functions that Nextflow provides. So like here's like, because people always wonder about this, right? There's like, this stuff was never actually documented anywhere. It just gets mentioned here and there. Here's all the extra functions you can access in the Nextflow Nextflow script. And here's all of the classes you can access. Some of them people already know about, but, like duration, memory unit. I'm getting a little bit off topic, but this is just a lot of cool stuff. And then value object. So this is an AST transformation that you can use for custom record types. It's really awesome. So you would have a class, and then you would say ampersand value object, and it will add basically just a ton of behavior. It's a combination of other annotations called autoclone and immutable. These are themselves compositions of even more annotations. There's a ton of them. Equals and hash code is one of them, but it basically just you add this annotation to your record type, and then your record, you're able to use it sort of like you would a regular like primitive value, right? You can compare records and see if they're equal to each other. You can use them in map keys, all this other stuff. So yeah, people are already using this because it's just really nice, right? And I guess they're just converting to tuples back and forth. And so, yeah, I haven't written any code for this part. I imagine it would look very much like the map type, where you'd have something like record, and then you would have the value, and then you'd have to specify the class, I guess. I'm actually not sure if this is possible yet because I haven't tried it. We might be able to just implement it as a new type. We might have to make more fundamental changes to the DSL syntax.
Can't say that at the end, Ben, after you've got us all excited about these new features.
Well, no, I'll tell you, like, the custom record types, it's on our roadmap. So we're going to get it done one way or another. If we have to make a DSL3 just to make it work, then gosh darn it, we'll do it.
Yeah, this is great. And again, coming back to the NF validation plugin I mentioned earlier, we were talking about last week, we've been tying ourselves in knots trying to make the metamap immutable so that you can't accidentally mess with it during a pipeline run. And we thought we did it, but then it was a bit buggy and it doesn't work. And I think you dropped a comment on that issue thread in that repo saying, hey guys, maybe you could do this with a class object or a custom record instead. And now, I didn't really understand what you meant at the time, but the pieces are kind of falling in now. That if we can have a custom class object and then make that immutable, and maybe that will work. So I'm going to come back to you with this one.
The other issue that I've heard about with record types is that the caching sometimes doesn't work. So like if you try to like resume a pipeline, it won't quite work. I think we fixed that in recent versions. It had to do with how the type gets serialized into like the Nextflow cache. And I think we figured it out. Similarly with like enums, you can have enums, and there's all this like low level stuff that comes up with that. But yeah, our goal is definitely to have more sort of first class support for both maps and record types. For maps in particular, another piece of it is supporting it more in the operators. So, there's certain operators like join, group tuple, things like that sort of need like a map equivalent. So we need like a group map and like a join map. Or just a join that works on both, right? Because that's sort of the main pieces you need if you want to convert all your tuples into maps and do everything by name, right? You would need support for map types in your process, and then you need to be able to use them in all your sort of like reduction fancy operators. So if we get those two things done, then we'll have a lot better support.
Makes sense.
Yeah.
And also to anyone listening, if you are already using maps or already using custom records in your pipelines, it'd be brilliant to see them, because I have a feeling there are some out there, but I can't think of very many examples right now. So drop us a line in the Slack channel, the channel's podcast Slack channel, because I think that'd be really helpful. I imagine, Ben, to like sort of see how people are using and test out that existing code base with whatever new fixtures we have coming out.
Absolutely.
All right. Any more stuff on processes, or have we exhausted your backlog, your roadmap? I mean, there's only so many lines of code in a typical process, but I feel like we've got new features for almost every line there.
Yeah. I think the Arity and the nullable and the default values are all in really solid shape. I think hopefully we'll see at least some of them in the next major release. And then the other ones, of course, still need some more work. As for the map and record types, like, it may be something we can deal with now, or it may just be something that gets folded into some sort of DSL3 effort. Of course, that is a whole nother topic on its own that probably we can do another episode on. But I will say that if we do a DSL3, it will be significantly easier to transition to than DSL2. All right, so don't worry, guys. It'll be don't get all your things in it. It'll be fine, okay?
We don't need any hate mail just yet. Cool. And if anyone's listening who's interested in these topics, we'll put the links to all those pull requests in the show notes, so you can go and dig into the code and leave some feedback. All right. Should we wrap up on our regulars, Marcel? Have you got any new content for us?
Yeah, sure. So we have a very nice post on the Nextflow blog, reflecting on 10 years of Nextflow awesomeness, and that's what the post is about. It's very nice to see, again, the story like from where it began and how much we've done so far and where we are heading. It's very, very nice. A very nice post written by Noel Ortiz. So it's very nice. I suggest the reading. Another very nice one is another blog post also on Nextflow blog, which is this Nextflow Docker murder mystery, the mysterious case of the OOM killer. I love this blog post by Graham. It's very, very nice. So there's an issue that some people, some customers, and even other users were running into, and it was like very mysterious. Like containers weren't working properly. They weren't being created the correct number. They were being killed out of memory. Very weird errors. And Hardy gave a very nice tip to look at the kernel. And again, it was a kernel bug. It was in the version of Linux that Amazon was shipping. We couldn't just say don't use it. So in the end, on the tower side, we after we understood the issue, we found a solution. So it's working now, and you can even use Fusion if you want to also fix that. It's a very nice read. I don't want to give all the spoilers, right? But I mean, it's very nice to see how from people who are like completely lost on what the hell is going on, and then part by part they were identifying what was going wrong. They found the issue. They found a solution. I really like the title. It's like a movie. I recommend you to read it.
I think this also gives a nice insight into the kind of depths that we sometimes have to go to find these weird errors. Like just the level of detail that Graham's gone into here, and Georgie as well, to track down. I mean, going down to kernel bug level. I mean, that's pretty extreme. So hats off to them for mad skills on being able to do it. And also, I really enjoyed the graphic here of the Docker whale upside down with all the containers floating away. I thought it was good. Considering the topic's pretty dry, they managed to make this into a really entertaining read.
This is a major shout out to Jordy in particular, because there have been a number of cases where mysterious Nextflow errors like this end up being some sort of kernel bug that he finds. He's really doing the dirty work that none of us else want to do, digging into the depths of the Linux kernel. And, we think of Linux as being this thing that like just works and is perfect, that because, it runs everywhere. So it's got to work. Right. But, there's actually still bugs in there. And it's incredible to think that like we're the ones as a team who is still uncovering bugs. It tells you that we're on the frontier of doing this kind of stuff,
I think that's the one of the great things about like Sequera being the company behind Nextflow, maintaining the development, the main developers. We really know what we are doing. You really understand the whole stack, and that's how we are able to see it's not on Nextflow, and we can go deeper and find the kernel. Many other companies and people are using Nextflow and providing Nextflow, but it's not compared to the expertise that we have in Sequera.
Yeah, it'll never feel that way though, because people will just keep running Nextflow in more and more places and finding new kinds of bugs, and it just keeps going.
That's a good problem to have, though.
Yeah.
On the events front, I wanted to flag quickly an event. Actually, it's not upcoming; it just happened last week. But you can still confusingly register for it and get the link to the recording. It was a lot of fun. This was a Sequera webinar. We called Nextflow Best Practices, Leveraging NF Core Tooling and Standards. So this was one I did with Harshal, but there was quite a few people involved in organising. And basically, we ran through here pretty breakneck speed all the different things we have with NF Core, pipelines, modules, sub workflows, and then Harshal, hats off to him. He did like a 20-minute plus demo, created a pipeline from scratch, went all the way through to running it on Tower, and he didn't hit a single bug. Like I don't think I've ever done a live demo that complex where nothing went wrong. So I think he deserved a beer after that.
He achieves Apollo level demos.
Yeah, exactly. I think Paolo does his demos do sometimes go wrong, but he's just so cool with the way he like runs through it, but no one notices. Everyone assumes that was meant to happen. So yeah, we had loads of people come to it and a lot of good feedback about that. So check it out if you're interested. I can put the link in the show notes again. And then of course our regular now note to the Nextflow Summit 2023. Barcelona in October 16th to the 20th, and Boston in the US November 28th to the 30th. We should hopefully have a new website going live. Hopefully it should be live by the time this podcast airs, right? So hit up summit.nextflow.io, and all being well, you should see a shiny new website looking wonderful with all the details for both events, and you can hopefully register. Also submit the call for abstracts should be open, so you should be able to pop in an application to give either a talk or a poster. So please, for my stress levels, don't leave it until the last day to submit your talk. We're going to be submitting them in as we go. And other big news as well for the summit is we've got our first keynote speaker confirmed. So now we know if you're going to the Boston event, we're lucky to have Eric Garrison is going to give us a keynote talk. He was really heavily involved in the Human Pangenome project, which was recently published in Nature. So some really, really cool stuff. And he and others, Simon Humus, for example, have been heavily involved in the NF Core community as part of that project to build the Pangenome NF Core pipeline. So really cool science, and also highly relevant for the Nextflow and NF Core communities. So I'm really excited about it. I'm getting that buzz already. It was still months away, but I'm psyched.
Oh, yeah. I'm right there with you, man. I'm so excited.
All right. Unless you guys think I've missed anything, I think we're about done for today. Coming up on the hour mark, so we're reaching into these longer podcasts now. It seems to be becoming a norm. There's too much good stuff to talk about.
Yeah.
So thank you, Ben. Thank you, Marcel. Ben, we're going to have you back on. We've got much more to go through. So we'll see you again in I guess a few weeks for more Nextflow syntax goodness.
Sounds good to me. Yeah.
And until then, thank you everyone for joining us, and hope to see you again in a couple of weeks.
Hello.
Bye, everybody.
Bye.